Good day to all. Now, the third module of this GPRS overview course, and this is the last submodule, that is the GPRS air interface. In this module, we will discuss the GSM air interface and GPRS air interface logical channels and how these logical channels are multiplexed on the different physical channels. There are basically two possible options for GPRS air interface channelization or multiplexing. Option 1, we can see here the use of existing GSM signaling resources for GSM and have the separate packet data channel. Option 1 means the signaling resources are the same as for the GSM, but they have different packet data channel resources. In the GPRS, packet data channels are also capable of carrying signaling information. With this option, the GPRS mobile basically comes on with the broadcast channel of GSM and use the common channel, common control channels of the GSM, and for the traffic, it is asked to switch over the packet data channels. And second option, here we can see here the option separates out all the GPRS resources from GSM. And there are several possible combination of channelization within this option. It depends on the vendor what they are implementing, but with this option we can have the broadcast channel PBCH, physical broadcast channel, which will carry the GPRS BCH information and common control channels, and can also carry the small GPRS packet data channel. If the PDCH are not with the physical packet broadcast channels or additional PDCH resources are required, then separate the time slot will be configured for this. PVCH means packet broadcast channels will not use time slot 0 since it does not contains the frequency correction channels and synchronization channels. Hence, the mobile will have to use the GSM for camp on process to camp on the BCH, and then on the BCH information system information type 13 system information message will inform MS about the packet broadcast channel. All these information regarding the PBCH are transmitted on the GSM broadcast channel information, that is the system information type 13. Now we have defined the several logical channels for GSM and for GPRS. All these logical channels definitely don't need to separate physical resources. The logical channels are mapped over the physical channel by using the concept of multi-frame. A multi-frame is a set of fixed number of TDMA frames where TDMA frames or a group of TDMA frames will assign us some functionality. Right, for GPRS, we define a multi-frame of 52 frames, and these 52 frames are further divided into 12 block. We can see here the B from B0 to B11. Each block made of 4 TDMA frames, and it numbered from 0 to 11. And these blocks are also referred as a radio block. And these 12 blocks will now be assigned certain logical channel functionalities. Apart from these 12 radio blocks, which constitute 48 TDMA frame, there are 4 additional frames left in this 52 frame multi-frame structure. 2 single burst frames are used for timing channels, and remaining 2 are kept idle for neighboring cells, basic decode, and interference measurement for power control. Now, after understanding the common RF multi-frame structures, the RF processes and operation, it's time to get the back to the information being sent on the air interface. We have already discussed about the briefly coding on the radio interface. Here we can see the radio interface has a maximum limitation on the data transfer rate up to 171.2 kbps. Here there are different 4 coding scheme. We can see here 1, 2, 3, 4, CS1, CS2, CS3, CS4 for GPRS network. 1 TDMA burst can carry up to 114 bits of information, and hence each radio blocks of 4 bursts can only carry how many bits? 456 bits of information. What is this information? This information basically contains the user data and coding. Coding means some redundancy we are added for the error detection and correction. The common process used in the GSM coding was inserting CRC bits and convolution encoding. And here some mechanism for GPRS traffic, also the same mechanism for GPRS traffic also. But the major which comes over here is that we have 4 options of coding the data in the different ways. With each options, we comprises on the level of coding and hence increase the probability of errors. But on the other hand side, increase the throughput. The above table, we can illustrate the process which we do. As we go higher on the coding scheme, we reduce the CRC bits, which will reduce the probability of bad frame detection. We also do puncturing, by which we remove some of the protection bits, and hence this leaves us with the less than 100% protection on the bits. So if the radio interface is poor, we will suffer from the errors. There are several ways of assigning coding scheme. The coding scheme will assign in the initial channel assignment process, but later the coding scheme can be toggled using the control bits on the burst. The coding scheme will play a very important role in optimizing throughput on the air interface. Remember, it's not coding scheme, it is the air interface quality which govern the throughput. And this one is the last slide, that the GPRS mobility management, for mobility management states apply both for mobile as well as GSM. For GSM, it is only the idle and dedicated mode, but for GPS, there are three states. Mobile have 3 states, that is the idle, ready, and standby. Idle means mobile is powered but not attached to the GPRS. And what standby means? Mobile is powered on and attached to the GPRS, but no packet transfer is in progress. Routing areas or updates are sent as needed. Third one is the ready. In this state, the mobile is actually currently engaged in the packet data transfer, right? And this ready state determined by a timer. There is no need to page a mobile in the ready state. Thank you to all. And this is just a completion of overview of GPRS network.